Well, and another thing about Ptolemy's model, I think, is so interesting. Up to that point, I mean, people knew that planets went into retrograde
Hmm.
before him, but uh, but he created a physical model. He
Yes.
said the fact that he said that not only do planets his planets in Greek is wanderer. They so the planets, while the stars all had a smooth arc in the
Hmm.
sky, the planets would wander
Hmm.
because they went forward and then back, and then instead of the planets just wandering, he said, "Well, let me come up with a model to say why."
Three, two, one. Welcome to Love Machine.
Welcome to another Nerding Out with That Nerdy Catholic. I'm here with my ever co-nerd Cesar, and we are continuing our look into the world of classical physics. Before we jump into that, I want to remind you, if you go to thatnerdycatholic.com, you can sign up for our email list to get updates on when we're putting out new videos and new things that are happening. You can head over to thatnerdycatholic.com/merch to get your nerdy t-shirts and mugs. And you can head over to thatnerdycatholic.com/support to help us support us financially. And I want to thank everyone who so far has been able to help us out. And I also want to thank everyone who has supported us in your encouragement, in your prayers. And I also want to remind you, if you we appreciate any time that you share these videos with your friends. We read every single comment that you leave, so we want you to be part of this conversation. So as you're watching, any thoughts, any questions, please leave them in the comments below. And so as that's pretty quick. I think that's the quickest time we've gotten to the intro. So let's jump into it. So where are
Okay.
we going to next, Cesar?
So we are going to the Roman Empire this time. We are going to talk about Claudius Ptolemy.
Mhm.
No, um, about his date of birth. There's a mystery around that. Some say that he born about 85 um, Anno Domini,
Mhm.
or some scholars say that he was born in 100 before the birth of Christ, no, 100 years. I'm sorry,
Yeah.
after the birth of Christ, no. So that's kind of the range.
Mhm.
He may live until 165
Mhm.
AD, or sort of about that, no.
Mhm.
So we don't have that much clear. But what we do know is that he lived in Alexandria by the time that the Alexandria was part of the Roman Empire,
Mhm.
no? So if we do a little history here, we see that around 30 before Christ, Rome take over Egypt, the
Mhm.
whole Egypt empire, and that became another province of Rome. And Alexandria became kind of the second largest city,
Mhm.
just behind Rome,
Mhm.
um, on population. No,
Yeah.
so Alexandria will continue with that development, but right now, Rome being supreme around the land, there was not that much funding for astronomy.
Mhm. Mhm.
So what we know about Claudius Ptolemy is probably he was one of the greatest astronomy during the Roman era,
Mhm.
which there wasn't that much.
Wasn't that
No.
much? Yeah. We still have. I mean, so he was in Alexandria, so
Mhm.
he was there with the library was still there at the time,
Yes. Yes.
I learned at one point this last week looking into him that there was also a museum
Hmm.
in Alexandria where he probably worked.
Oh, interesting. Yes.
But so he was surrounded by probably the intellectual capital of the whole
Yes.
region.
Yes.
And so he was, even if there wasn't a lot of funding, there was still a lot of this, you know, knowledge that had been passed down from before him.
Yes, that's completely right, no? And we have to say that Ptolemy was kind of multifacetical, let's say, scientist. No, he was very good in mathematician, astronomy. We got also astrologer, geographer, and theoretical musician. So there's a wide range that he covered there.
Yeah.
No, and there are. So he wrote more than a dozen documents, but there are 3 documents that have very much influence in the Western civilization, in the Islamic and Arabic civilization, and and in the Byzantine Empire. If you remember, at some point, the Roman Empire was divided in 2. Roman fall in 400 years after Christ, but the Eastern Roman Empire, which became the Byzantine Empire, survived 1,000 years more. So that his influence was all over the known world, even beyond Rome. We are talking about the Arabic and the Islamic world also has a lot of influence. No,
it shows that, like we've talked about before, we talked about this in the early episodes on math. Because of the trade that was happening in the world at that time, there was also a trade of knowledge,
yes,
and intellectual ideas that were being shared. When we were talking about the Arabic numbers starting to be used in the West. So anyone that was coming up with new ideas that made sense and that worked were being shared throughout the world.
Yes, and not only that, ideas and knowledge, especially if we have the Byzantine Empire, which was self-sustained mostly on commerce. No? So that's a good thing to say.
Yeah.
So we were seeing that there were 3 things that he influenced the most in these 3 words. No, let's say the first one is the astronometry. We are going to talk deep about the astronomy. The second one is the geography. No, he actually made very good progress on geography that we still use in these days. The third one was the astrological treatise, which we would say, why astrology? It influenced the way of thinking of that time. No?
Well, and think about the tie between astrology and astronomy. We think about astrology now as, well, only uneducated people think about astrology. People that don't understand, astrology makes even less sense now that we understand that the Earth goes around the sun. I never really followed much about astrology. I just remember reading the little snippets in the newspaper. But I remember learning the one thing they say, when someone says, a common phrase in astrology is say, well, when Venus is in retrograde. And so the terminology within astrology only makes sense in a geocentric model, because as we're gonna be looking at his model of the universe, you can only have a planet moving backwards in a geocentric model.
Yeah.
But astrology was used by the intellectuals of the day. They were in a world where you had multiple gods, and the gods were in charge of different parts of the heavens, and then your understanding of the universe, astrology is a big part of it, understanding the movement of the bodies in the heavens.
Yep.
And so the tie between astronomy and astrology is very strong, because you need to understand the movement within the heavens to understand the meaning behind it.
Yes.
And I would feel safe to bet that astronomy would not have advanced as early as it did if it weren't for astrology.
Yeah, it keeps the interest of the people to look at the stars. That's true. The only one thing that I would add regarding his personal life was although he's considered Greek, because Ptolemy is very Greek name. The fact that he's Claudius Ptolemy tell us that he was a Roman citizen. No? And that means he has kind of some privilege and access to knowledge that probably most people didn't because of the influence of the Roman Empire at his time. So that's about to say about his life. So we will start on what were his contribution, but before that, again, we always say that physics is based on mathematics and math.
Yeah.
And his math, he has very important contributions with math. We are going to touch base very quickly because that's important to understand why he can develop his astronomy and geography. He was the first one on developing a lot in trigonometry. So of course, if you're going to see the star trigonometry, sine, cosine, tangent, those are very important functions to determine the positions and the distance from stars. The second one is he was also very good developing something related to optics. I didn't know that. So he started discovering that the angle of incidence in a mirror is equal to the angle of reflection. And he even discovered that the light changed its path if it passed from one physics way to another, say air to water or something like that. He didn't discover the law of Snell's law, which is how much the light bent going from one material to another, but he discovered that bend, the diffraction.
He wanted to save that for someone else.
Yeah,
he didn't want to take all
probably.
the credit. Yeah.
He and what, and of course, there's a lot of treatises of circles that he made. So that per se give us him a very good mathematical foundation for his work on astronomy and work on geography that we are going to see after. So again, I want to emphasize this. There's no good science if you don't have a very good math foundation. So that's the first thing.
So all of you out there who are struggling with your math classes, if you're interested in science, keep working on your math.
Yeah, that's very important. The other one is the first one we are going to touch is the geocentric model. That's why he is known. He's known to have the geocentric model, and let's say that his model survived. His model survived more than 1,400 years before Tycho Brahe came and replaced his model. We are going to touch base in some episodes coming about Copernicus, but we will see, similar to Galileo, that Copernicus again proposes the sun-centered model, but was unable to have data to back up his claim. Galileo is the same. So we have to wait until Tycho Brahe, which we are talking about 1600 here after Christ. He was the one that developed the instruments for precise measurement and was the first to say, hey, something around Ptolemy's data doesn't make sense. But that's 1400
I know. Well, yeah.
years later.
So as you've seen before, there was a very long period where that was in question.
Yes.
Where there was the model of everything going around the sun was proposed, but as you said, it took longer for us to be able to have the equipment to be able to measure and to show, maybe not even prove, but show that there's pretty good likelihood based on both the logic and the math and where you could actually observe that we went around the sun. But as we've noticed before, to have a model so strong that it lasted for so long.
Yeah.
Even as we know now, it's wrong.
Yeah.
With what they had and their understanding of the world at the time, it made sense.
And this is important to notice, though. So it was not only the Western Christian world that adopted his model, it was
Mhm.
also the Byzantine Empire, it
Mhm.
was also the Islamic and the Arabic world.
Mhm.
The known world completely adapt his model, no?
Mhm.
Adopt his model. That's very important, and we are going to see why.
And it's also very important to state his model based on the universe. His model of the universe was based on a globe.
Oh yeah,
As you've said before,
yeah,
you know, the whole idea of the Earth being flat is very ancient
yes,
and very new.
yeah,
You know, that there are people now that say the Earth is flat.
yeah.
But
I know.
for, over 2,000 years,
Hmm.
it would have been very hard to find someone that actually still thought that the Earth was flat.
Yes, that's correct. His model also present the Earth as a globe.
Mhm.
You're right. You're right, and that's how it's pictured in his representation,
Mhm.
physical representation of the model. No, but let's see. So he has the idea that the sun and everything revolves around the earth, no?
Mhm.
Like Aristotle. He has a very good foundation on Aristoteles too. But let's say that there was a guy named Aristarchus of Samos, from Alexandria also, who came kind of around uh, 350 before Christ, that said that it was the other way around. It was that the earth was going around the sun.
Mm.
But here is the detail. He wasn't able to present data that support his
Mhm.
idiocentric model.
Mm.
So
Yeah.
that was the key here. No, the second thing is that Ptolemy know that this guy has put it up this model, but he reject that on the fact that there was no data that
Mhm.
to support his claim.
Mhm.
On the other hand, Ptolemy, having access to the Alexandria's library,
Mhm.
he have not only his data that he take, but he have data from older people that has collected, and he start his study from that data collection
Mhm.
and his current observations to say, oh, the Earth is the center,
Mhm.
everything moves around,
Mhm.
and this is the way that it moves around.
Yeah.
So he started putting some tables together, and with those tables of data, he was able to predict celestial movements
Mhm.
and like celestial events like eclipses and other
Mhm.
things like that. No,
Yeah.
so that is very important to say about Ptolemy. Ptolemy doesn't just say that the Earth is stationary and everything else is moving around the Earth.
Mhm.
He have data to support his claim.
Mhm.
No, and with that data that he pulled up, people were able to estimate with the precision that at that time was allowed to where are going to be the future eclipse, where are going to
Mhm.
be any other celestial events that they can
Mhm.
see. No,
Yeah.
and when they see something, then they have data, and the data predicts what it's going to say. So that was accepted model.
Yeah.
No?
Yeah, and I think that's still one of the main standards of science today,
Mm-hmm.
is that if you create a model and you have predictions about what's going to happen based on that model, if those predictions come to pass, well, that model seems to work, right?
Yes, exactly.
And so even as you keep saying, a model that was not correct, it still made sense and predictions worked based on it. So
Yes,
there, at the time, there was no reason to question it.
exactly. And the second thing is, similar to Aristoteles also, he also thought about the earth and several layers of circles, each one in each circle, there was, the sun, there was the other planets moving around. No, but here is the key on his model. No, he noticed that if we just left it like circles, there was a difference between what we see and what his model said. No, so he invented a new term here that is the epicycles. So imagine that this is Saturn, for example, going around the Earth. The epicycle said that even Saturn is moving in circles around something. No? So there are two movements in every planet: the movement around the Earth, and the epicycle saying that that planet is moving around something in circles. If you combine the two movements, you will see that there's
some of the you have like loops going around.
Exactly.
Yeah.
No, so that's why you say that there. What was the term that you say?
In retrograde. Yeah.
Yeah. It only makes sense if you have his model, because in some way, doing the circle, you are in retrograde, or in other forms, you are moving forward or towards the Earth.
Yeah, I've seen time-lapse shots of Mars where it looks like it's going across the sky, and every once in a while it turns back and it goes backwards. And as we said, so much of astrology is based on that motion. And if someone needs to know, well, when is, if you believe that your life is guided by Mars, and you want to know, well, when is Mars going to be in retrograde? You need a precise model.
Yes.
To say, okay, Mars will continue to move forward. On this date, Mars will start to go into retrograde for this number of days, and then it will go. So he had such a precise model. Yeah, it was amazing that he could predict when that was going to happen.
Yes, exactly. And this is really important, because that was most of the pagan world. See the sky and see the gods there. No, so they immediately see a model that can predict those things. They adopt it. No, and
well, and we even see that in the Bible. We did a whole episode on the wise men that came to see Jesus.
Yeah.
How did they know where to go? They looked at the stars.
They look at the stars.
The stars guided so many people's lives.
Yes. We say that this was the model that spread all around the world, and even in, let's say, because in the future we are going to talk about Copernicus. Copernicus have the opposite idea, that the sun is the center, but the only thing that Copernicus wasn't able at his time, and we are talking 1400 after Christ, is to pull up data that competes with Ptolemy's data. Yeah. So
well, and another thing about Ptolemy's model, I think, is so interesting. Up to that point, I mean, people knew that planets went into retrograde before him, but he created a physical model.
Yes.
He said, the fact that he said that not only do planets, because planets in Greek is wanderer. So the planets, while the stars all had a smooth arc in the sky, the planets would wander because they went forward and then back, and then instead of the planets just wandering, he said, well, let me come up with a model to say why they go backward. Well, they're circling around the Earth, but they're circling around something else, and that, using the geometry and trigonometry to create this model to say they're going around an epiclesis and going around the Earth, so therefore here's the model that fits.
Yes, and this is how you
use, and it's a logical, mathematical,
exactly,
and with his understanding, a very scientific model.
even though most of what data is based, the only thing that is really sad is that we don't know which data was Ptolemy based, because when the Muslim Empire took over Alexandria, we lost everything after that. No,
Yeah.
but they were able to extract that data from Ptolemy, and it is known that the Muslim, instead of coming up with another model, came up with a correction of Ptolemy's model. So they really believe that was the geocentric model, but because of the imperfections, the Arabic world has developed also optics and look at the sky. They were able to correct the model to make it more precise.
Interesting.
No, so they didn't come up with a new
There
model.
are a lot of things that they rejected, but
Yeah.
they accepted and
yes,
improved on his model.
yes,
Yeah.
exactly. So this is a very good thing to know. That correction from Ptolemy's model came back. You remember, we have to remember here that the 12th century after Christ, no, we have a very weak right now Byzantine Empire. Roman has fallen centuries ago, and the Western world was, in the Western world we were creating the universities, no. So the Western world started to know again about Ptolemy and the correction of this model because of that new trade that is happening.
Right. We had people coming in from the Arabic world
Yes.
into Europe for the universities, right?
Yes, and the Almagest, which is the name of the book that Ptolemy wrote about astronomy, was translated first to the Arabic world from the sources of Alexandria, because remember, they came to Alexandria, they conquered that.
Yeah.
That part right now is Muslim Empire, and that word was retranslated to Latin because of the trade that was made. No,
right.
but it is funny how we came to know about Ptolemy. No,
Well, and at the time, this was hundreds of years before the printing press.
yes.
So at the time, any work that had to be done had to be handwritten. And so how important did they see Ptolemy's work that anyone who saw it, that it was first translated into Arabic, and then when it came over, that it was translated from Arabic into Latin. The work of translating a work like that from one language to another and making multiple copies was
a tremendous
a lot of work.
Yes,
and so it must have been seen as very crucial and important work to keep around to make sure it survived.
Yes. So it was considered a really important work in the whole known world at that time. Yeah. There's another important information that Ptolemy sent us, which is related to geography. No, the story say that, and it is in one of his writers. That is, I'm going to try to speak Greek here. Geographicae Eifigesis. I'm sorry about that.
We'll put that up on the screen.
Yes.
They say it's all Greek to me, right?
Yes, literally, it's Greek.
Yeah.
No, which means guide to geography. No, he write his book about geography based on the data that was obtained of the Marinos of Tyre, which was one of the sailors of that time. No, and we only know about this guy because of Ptolemy. Ptolemy referenced him in his book, saying that his data was very important to have his treats on his book on geography. No? And so we have to remember there was not America at that time. We got only the known world from some coastline of Africa, that part of Europe, and the Western world, the Arabic world at that time. That was it.
So you have from as far northwest as England,
Yeah,
down through Asia.
Yes,
in Africa.
and
And
Africa.
that
Yes,
was what we knew of the world.
that is another word. And for that word, he was able to come up with maps. And this is the nice thing. He put precise location, meaning latitude and longitude, for 8,000 locations.
Wow.
8,000 locations. This is the latitude and this is the longitude. So he came with the concept of latitude and longitude. We still use that concept today, no? To know what is the precise location. We
Right.
still so use that concept where GPS is based on that to give us the accurate information.
Well, and he also wasn't he was the first one to show a flat representation
Yes.
of the
Of
map of the globe.
Exactly, and this is very important, no? Because it's not that they believe that the Earth was flat. He believed that the Earth was round. And again, we have to get back to math here, because how do you represent the parts that are in the northern or southern part of the globe? You have to stretch those.
Right.
And how much you stretch, you make your calculations based on map. And you stretch that map and put the latitudes and longitudes there.
Yeah. And why do you have a map instead of a globe? Well, if you're on a ship, and you can't be referencing a globe all the time. You have to have a map flat down to be able to navigate.
And remember that is the time of papyrus, so it's something that you can easily scroll, give it with you, share the knowledge. The beautiful thing about this is that because he has the idea of latitude and longitude, it was easy for other geographers to copy his map, because it's like you have like
the grid lines.
Grid lines, and you copy precisely the different positions because you already have the grid line, no? Which is something nice. So I say that we have to thank Ptolemy because of the latitude and longitude concepts, no? And that was able to develop very accurate map for that time, no?
Yeah.
And that's really important. Those geographic. His geography book, again, the Muslim Empire came, grabbed his geography, they use it, and they came back to Europe in 1300 AD. No, that map from Ptolemy, which was again to the Western world.
Yeah.
But it is really, really interesting that even besides the religion, the science is valid. The science is valid for the Christian world. The science is valid for the pagan world. The science is valid for the Arabic world, for the Muslim world. Because they understand truth there. You know? Ptolemy's work makes sense with the knowledge that they have at the time. He makes sense with the data to provide for that knowledge. To say, okay, this is what you say. This is the data that you have. Am I able to predict movements with this data? Yes, I adopt your model. There's no question.
Yeah, there's no well, these are Western ideas. Therefore we're not going to accept it. We have our own ideas. They recognized the precision and the truth in it. So why why wouldn't they adopt it?
Yeah. So those are the two things that two big things. We are not going to go deep into astrology because for us it didn't make sense.
Yeah. Although I think the main thing about the astrology, like we said a couple times, it was the driving force behind astronomy.
Yes.
Behind understanding, so I really think we would not have the image of the universe that we have right now if it weren't for that. Because that was the driving force for hundreds of years.
Yes,
because to understand the movements within the heavens.
Because it was a way to understand the God's will, and that is very important. The humans want to determine the destiny, and as long as they want to know what is God's will, they will try to do that.
Yeah.
So that's a really important remark. Thank you very much for that, Seth. No, some of the conclusions that we have to take from our adventure with Ptolemy is, the first one is he was a scientist that, based on math, was able to produce a geocentric model,
Mm-hmm.
you know, that can predict the eclipses and all the celestial movement.
Mm-hmm.
You know? So that's the first thing, you know. The second concept is that, you know, as you said, I didn't know that planet in Greek was wanderer,
Mm-hmm.
which makes sense because, you know, the stars move all together
Yeah.
nicely,
Yeah.
but the planets make those movements, and those movements were explained by the epicycle
Mm-hmm.
that he proposed.
Yeah.
You know,
Yeah.
and again, those are embedded in his theory and his tables, and all that make the vision of the universe that was taken and adopted
Mm-hmm.
for the whole known world. You know?
Yeah.
The other thing is that his advancements of trigonometry and math knowledge make him known, you know, not only the stars, but give us the data to make the tables for prediction,
Mm-hmm.
no? Which is
Yeah.
really important. Remember Aristarchus of Samos, he said, no, the sun is the center. Okay, where's your data?
Mm-hmm.
I don't have it.
Uh-huh.
No? Well, I have
Right.
it.
Right.
No?
Right. And,
Uh,
and as you talked about it, it's going to be over 1,000 years before someone
yeah.
started to try and get the data together.
400 years.
Yeah.
400. 1400 years.
1,400
Sorry,
years. Yeah.
400 years.
Yeah.
1400 years before we came up with data to support the heliocentric
Yeah.
model.
Yeah.
No. The other thing in geography, latitude and longitude, we still use that.
Mm-hmm.
I mean, we have to take credit for this guy.
Yeah. Yeah.
No, it's a really important concept. No?
Yeah.
And how do we tie it up with the Catholic faith? No, when I was in school, I was told that the Catholic Church adopted Ptolemy's model because his geocentric view was in accordance with the Bible, and that was the reason.
Mm-hmm.
So I before, you know, doing this episode, I say, well, why would it say that? No?
Mm-hmm.
And yes, the Catholic Church adopted Ptolemy's model, but probably not because what is in accordance with the Bible.
Mm-hmm.
It was because it was at that time a proven model
Mm-hmm.
with data that can make predictions.
Yeah. Well, as we said, everyone accepted
exactly
the model.
Exactly.
So the Catholic Church accepted it because everyone accepted it, and that's, as you said many times, that there's this misconception that the church has what it wants to be true,
mm-hmm.
and it's going to push aside any logic, science, or anything
mm-hmm.
that goes against what it says is true.
Yeah.
But the history of science, so much of the history of science, and we're going to be getting into a lot of these scientists, are Catholic because
mm-hmm.
they want to understand the universe.
Mm-hmm.
And so if it makes sense, if it fits, if it works, well, then, yeah, the church is going to accept it.
Yes.
Because the church is seeking the truth.
Yes.
And it's not just seeking, moral and religious truth. It's seeking, like we say all the time, the tagline of our whole channel, all truth is God's truth.
Yes.
No truth can contradict any other truth. And so yeah, the church is going to accept what is shown as true and can be represented and proven to the best of someone's ability at that time.
And just to prove that again, what you said is, Ptolemy wasn't Christian, he was
mm-hmm.
pagan.
Mm-hmm.
But his model was accurate with data
mm-hmm.
and was very good to make predictions.
Mm-hmm.
No? When that model was perfected by the Muslim world at that time and came back kind of 1,000 years later in 1200 AD,
mm-hmm.
with those correction and perfection, it was readopted again
Mm-hmm.
because it was safe, it was logical,
Mm-hmm.
it has data
Yeah.
that prove accurate
Yep.
what you see.
Yeah. Yeah.
So it is important to highlight that because I'm still, even though if you go to Wikipedia, it says that the church adopted the model because it didn't want the development of the science. Nothing more untrue like that
Right.
statement.
Right.
No.
Well, and I have really appreciated, first with the series on math, and now this series, I've come to a greater appreciation of, like I think it was the last episode we used this phrase. We only know what we know because we stand on the shoulder of giants.
Yep.
And so this slow development of our understanding of the universe over hundreds of years, and so the church, right along with the world, is saying, well, and the church in many times actually supported a lot of this later on. Let's understand how the world works. Let's understand how the universe works, what the universe looks like, what it's made out of, how things move.
Mm-hmm.
It's just a constant search for the truth.
Yes.
And a lot of the stuff that Ptolemy worked on, discovered, and created, as you said, we still use today.
Mm-hmm.
There are some things that he, we know now that the Earth goes around the sun, but our understanding of the fact that the Earth goes around the sun is built on a lot of the math and science that Ptolemy helped advance.
Yeah.
So even though it's so easy to say, well, Ptolemy's model of the universe was wrong.
Yeah.
Therefore, someone else had to come along and give the correct model. Well, that correct model would not have come if it weren't for the math, the trigonometry
Mm-hmm.
that he helped develop. The heliocentric model of the universe was created because he first had a very precise geocentric model of the universe.
Yes. Yes. And I would say I would challenge, without using a GPS, something like that. Try to come up with the, you know what I mean?
Yeah.
You have to put in the shoes of what they have at their time.
Yeah. Yeah.
It's
Yeah.
very important.
Yeah. Well, I want to thank you for joining us again for another interesting conversation on the history of physics. We had a good adventure with Ptolemy today. And so I want to invite you to continue to come back. I want to invite you to be a part of this conversation. If there's anything we said that was mistaken or wrong, please put your corrections in the comments below. As we said before, if there's anything we said was wrong, we'd love for you to be able to share some sources.
Mm-hmm.
Show us where we've made a mistake and why.
Mm-hmm.
And not just we ask, don't say science says.
Yeah.
But we would love for you to be part of this conversation. So please leave your comments below. If you head over to thatnerdycatholic.com, you can sign up for our email list to get updates. If you head over to thatnerdycatholic.com/merch, you can get the latest nerdy t-shirts and mugs. If you head over to thatnerdycatholic.com/support, you can help support us financially, and any support we highly appreciate, and we're really thankful for everyone who's been able to support us so far. So thank you for joining us again today. We look forward to seeing you again next time. Bye. God bless.
Thank you. Bye-bye.
System shut down.